Okay, so the course content which we have for today is we are dealing with exceptions, and this was one of the other topics which I took earlier when I was giving the demo classes in the starting. But anyways, like whoever has not attended can gain from here, and whoever had attended before they can have a refresher session. So the course contents which we have is dealing about exceptions which we have in Java and how to create our own exception classes. Okay, so uh, the topmost level of class which is there in Java is throwable. That's how it has been named. And if you see what is throwable, this is a superclass of all the errors and exceptions in the Java language. Only objects that are instances of this class or one of its subclasses are thrown by the Java virtual machine or can be thrown by the Java throw statement. So if you don't understand can be thrown by the Java throw statement, we'll see that later in the same PDF. But for now, just understand that throwable is a class which is a superclass, and everything which Java does is a type of throwable class. Okay, now there are two examples, sorry, there are two types for it. One is error and one is exception. Now the basic difference between error and exception is that error on one hand is about the situations, is about the interruptions in the program where you don't have any control as such, direct control. Obviously, I mean you can fix it, but there are not direct ways. For example, say if you start getting out of memory error. Now, out of memory error is not an exception. Okay, this is an error. Why? Because say I mean you have a lower heap size configuration for the JVM, and the program which you are running requires a higher configuration size. In that case, once the program reaches the value which you have set in your JVM settings for the heap, after that after that, if you require more memory, you'll start getting out of memory error. So do you have any direct control? No. Is the program responsible? In a way, yes, but I mean not directly. So what you need to do for fixing this, either you need to increase your heap size settings, right? And this is just an example, so it's not like all errors can be fixed by increasing the heap size. Okay, so here you can either increase the heap size settings maybe from 4 GB to 8 GB so that your memory requirements for the application can be fulfilled, or you can go and see like in my program which all objects are created, how much memory they take, and try to reduce those object creations. Maybe you are creating objects in loop which is not required, and you can avoid those situations. So in such ways you can do. The other errors which are say stack overflow error, out of memory I've already told. So such errors can't be fixed directly. Okay, they're not because of errors in the exception interruptions in the program directly. Okay, there might be an indirect association that because of something or there this is coming up, but there is nothing in the immediate term in the application which can fix this. So for example, null pointer exception, sometimes you get the exception as null pointer exception. Now what is null pointer exception? So null pointer exception is if something is out, there is null. And like say for example reference data types that are initialized as null in the starting, if you remember. So say if we have an object employee, right? If we have an object employee, and the employee in the starting we initialized it as null. Now we have not made it to point to a new object, and what we're just doing is that we're using employee emp is equal to null, and then we're doing emp dot get emp dot calculate salary. In this case, emp itself is referring to null. There is nothing to get out of here, so you get null pointer exception. Now that is an exception. Why? Because there is a direct reference in a program. You can directly fix it. Okay, but in case of error, there is no direct relationship. In fact, in most of the cases, there is nothing in the program which you can do to fix it. Okay, but only in some cases, like out of memory, which is told, you can find an indirect reference to modify your code base to reduce the memory footprint. And in most cases, wherever you have already optimized your code for that, you may not be able to fix it further, because that's still that particular level only that you can reduce your memory settings, not more than that, right? After that, you just require more memory, for which you either need to increase the heap size, buy some more memory. All that stuff has to be done. Okay, so this is the basic difference between exception and error class. So what is an exception? So exception is interruption, the normal processing of the program. You are doing you are running some program, you want some logic to be executed, okay, and because of some or the other negative scenarios, there is an interruption, and that is nothing but exception. Okay, so that is how we call as exception in Java. And what are the cause of exception? Many stuff, like say invalid data not handled in the program, negative scenarios not accounted for, spike in the number of users signing in, and this might be a reason for I mean your application getting down. So difference between exception and error. So error is out of control of programmer's control. Example, Stack Overflow error, out of memory error. Exception arises because of the code and the data related to it. So exception, if you see, is not out of programmer's control. Okay, it arises because of the code and the data type and the data related to it, and this can be handled. Okay, now let's come here. So there are two types of exceptions. One is checked exception, and the other one is unchecked exception. So let's go above and see what we have described here. So there are two types, right? One is IO exception, one is runtime exception. So what is runtime exception? So runtime exception, I mean the name itself will suggest you what it exactly stands for, right? So runtime exception is something which happens at runtime, okay? And IO exception or any other exception is something which we already know at compile time that it can happen. So on high level, this is how you can understand it, and that is what is referred by checked exception and unchecked exception. So there are some exceptions which at the time of writing a program, you know that such exceptions can come. They are checked exceptions. Now there are certain exceptions like say null pointer exception. You do not know at that point of time when you're writing the program, because of some reason or the other, that you will get that will get the runtime exception, right? So only while running the program you get an exception, and then you know that, oh, this has happened. So there is nothing out there which you can directly do to handle it, right? And that is called as unchecked exception. So unchecked exception is something which you have not handled in the code directly, right? And checked exception is something which you have, which you know upfront that it has to be handled. So that is a basic difference, and there is a very thin line drawn. So to understand the difference, you just have to take this into account. Okay. Now, what are checked exception? Let's go through the theory which we have. Checked exceptions are the exceptions that are checked at compile time. If some code within a method throws a checked exception, then the method must either handle the exception or it must specify the exception using throws keyword. So what it exactly means for, we'll look in with an example, but let's understand that checked exceptions, something has to be handled, right? We know upfront that some error will be thrown. Now coming to unchecked exceptions, they are not checked. You do not know upfront. Okay. So like say for example null pointer exception, they are it cannot be controlled. You can go ahead and catch those exceptions as well, and in that way that becomes when you catch it and you can throw as well, but that is not recommended. Okay, in general they are just unchecked exceptions. Now again, see here the throwable which I described above, then you have error which is unchecked, then you have exception, one was IO exception, then the other exception things, and then runtime exception. So runtime exception is something which you do not know upfront, they are unchecked. Okay, and there are other exception types which are checked. So examples of checked exceptions are like say here, right? So if you see this program, okay, now what we have out here is that we are trying to read a particular file, okay, and do it. Now there is nothing out here where we are trying to we are not throwing any error, we are not catching any error, we are not doing anything. But if you see, the source code is not it's uncompilable. Why? Because maybe the path which you have here is not valid. There is no directory such as test, okay, or maybe the directory is in D drive or some other drives. So in that case you are getting an exception while running. While compiling there is no error, right? This is how the definition is. This is string, this is acceptable, everything is done. But when Java tries to run it and actually goes and tries to find this particular file in the disk, so it goes in the C drive inside the test folder and sees where is a.txt. It doesn't find it. It throws an exception, right? It throws an exception, file not found exception. Now this is something which is an example of, checked exception is written here, but the thing is that this becomes checked if you do it in this way. See, throws IO exception, right? So here if you throws and this is checked exception because see, it says that it's uncompilable source code. So if it is, it should be, it's an uncompilable source code because the file not found exception was not thrown as such. So that's why this program might not be compilable at the first place. So to fix it, what we are doing is see, you have throws IO exception. So either your program as such has to like work on that exception, that is say catch it, or it has to throw it. So unless you do either of it, it's going to be you can't move ahead. So these are the two ways in which it has to be dealt with. That you either deal with it, okay, or you let the exception propagate. And the way to let the exception propagate is to get rid of this from this particular method. Now main is also a method, right? So if you do not handle it here, you have to do a throws IO exception, and we can just write it as well and see that how it works. But this is how we have defined it. So let's go here to our program and write another class, say file reader. So you do a control space, you'll get the options. You have to use this one, so you write that one. Reader is equal to new file reader. Okay, and the path, there is a path also I think we can give. The path which I gave is in D drive inside test 1982 slash 1.txt. Alright, now once you do this, just press save, control S. So if you see, it gives an error. Why? Because whoever has written java.io.filereader, okay, what they have done is that the method which they have written, that expects that you handle a particular error. And how is that enforced, I can say you, but for now just understand this is an example of checked exception. Okay, and the way to handle it is two. Either you handle it in this particular program itself. How do we do that? We add a try catch block. So this is how we write it: try catch and then the name of the exception. So you have exception exe. All right, now once you have this, you have to place this particular line inside the try block. So whatever is your code which can throw the exception, that has to go inside the try block, and then it has to, then the catch block has to be there. So now what this means is that if there is some error because this line or any such lines which you write here inside try block, there is an exception block which can handle to those particular errors. So you can do something, you can avoid to do something by just handling it like this, or you can print the exception, or you can direct the program somewhere else. So there are multiple things which you can do. So this is just a program, so you can do multiple things from here. So this is how to do it. So this is how you're dealing in the program itself, right? So if the code forces you to provide a fix to the exception, and the fix can be you handle it here or you throw it further, okay, then that exception is called as checked exception. All right, now let's go back and remove try catch block. So if I go here and remove try catch block, okay, now if you remove there is one way which was to add try catch block. The other way is to let the let the exception propagate further. How to do that? How to do that? Say write throws exception. Okay, now once you do this, what it means is, so what this means is propagate it further. So if it is out here, move it to one level further. So here, this is the last level, right? This is how you're going to run it. So see if I run it, what happens? You'll get an exception while running. Why? java.io.file not found exception. Why? Because main is the last thread. So throws, what it does is that it lets the exception trace propagate to the next level. Next level meaning to the method which called it. So once it goes there, it goes further to the next level, to the next level, finally to the actual main method which started it. So here, this is the main method which started it. There is nothing else to go from here. So throw the exception just signals Java that throw the exception to whoever is there, and this is how we get the exception from here. Okay, so this is the meaning of checked exception. So you're forced to do some fixes for accessing that particular method. So for example, let's say here in this particular class, if I write a method, say public say file, and let it return Java file. Okay, get file details. All right, and now what we're doing is we are expecting a string file name here. Okay, and then ending it here. Now whatever we are writing it, what this does is, first of all, it expects, and just to avoid the compilation error, we just write return null here. So what we are doing, it just expects that you throw a particular exception in case the file is not found, and the exception is, say, throws file not found exception, whatever Java has it, right? So we go java.io.file not found exception, we do it in this way. So what this means is that if you do not find the file, propagate it further. So what we can do is that, say, if null is equal to file name, all right, then in that all the suggestions which it comes with is with control space. If null is equal to file name, throw new file not found exception, and here you can even give the message. So if you go to the next one, you say with the specified detailed message. So you can go ahead and write, hey, where is your file? Okay, so for now just let's keep it here. All right, and since we're not returning anything, it's showing it in that way, but let's say return null, just to avoid the compilation error. And from here we'll try to since it is not a static method, we have to create an instance of the class. So instance of the class creation means create a new object. So I go here, create new file reader, but this I think is actually referring to java.io.reader. Okay, I think I need to use this one. We'll go here, use this one, dot get file details. All right, and here I just pass null, and let's see what happens, right? So here if I pass as null, okay, and this is not the actual definition of the main method, right? So if I do it like this, see, this gives this gives an error, and here I'm not using any of the Java inbuilt stuff, right? And what I'm doing is just using my method get file details. Until now it has not even gone and tried to open the particular file. So why is this giving error? Because this is a way in which we throw the error. So even if you write your own custom error, sorry, your own custom method, and you want that particular method to throw the exception, you declare it with throws file not found exception, okay, or with any exception you want to throw it with. And once you do that, the method from where this thing is getting called has to handle it. How to handle it? You add a try catch block here, or let it propagate further by adding the throws block. So this is how we do it. Okay, now if this is the case, all right, now let's say for example file not found exception is something which is, someone is not on mute, please go on mute please. Now so file not found exception is Java exception. Say I do not want the Java exception, and the reason can be many. The thing is that Java exception lets you give the message, etc., but depending on, like, say try catch blocks were there, right? I do not want to catch any of the exceptions from Java, okay, what Java is already defined. I want to define my own custom exceptions. Why? Because those custom exceptions will signal me something different, okay, and that's why I want to handle it differently. This is one of the reasons. The other reason can be, say that I want error codes, specific error codes which I have put, and Java error classes, like say this one doesn't have any attribute for exceptions, right? So let's, for example, let's see also which options it has for new file not found exception. Now it only has two things. One is without any message, one is with message. So most of the exception classes don't give the option. So there is an you want to create your own exception, or maybe from your exception classes you want to go ahead and say um, you want to go ahead and trigger a new you want to create your own custom trace, okay, or you want to give some specific scenarios. So those stuff can define your own exception classes. So how to do that? Say I go here, I go and do say new class. So if I do a new class and say I will just want to write training exception, okay, because this is my application, I want to say as training exception. So I create a new class training exception, okay. Now if I create training class a training exception class, how does the program know that this exception class that this is an exception class and this is not a normal class? How does a Java know? So it has to inherit the features of an exception. How to do that? When I use the word inherit, it implicitly means some sort of inheritance is there. We need to extend some class, and that class is exception. The classes we should discuss. And see, this is a base class java.lang.exception. So go here, select it, maybe, and click on finish. All right. So if you see here, the class got created. Okay. Now I'll go here and say add say private string error code. All right. Private string. Sorry, not like this. Private string error code. Okay. And maybe define my own constructor as well. Public. Okay. Training exception. Expect error code here. Okay. And maybe you want a message as well to go, which I have not defined as an attribute here, but that needs to go in the super class, so you can define it here. Okay. Then we'll go here, we will say super. Okay. Why? Because we are calling the super class constructor and pass the message. Okay. And after that we are trying to set the error code for this class, right? This dot error code. And if you remember my earlier classes, why is this required? Because the name of the variable and the name of the class level variable are same, and we want to set the value for the class level variable. So that's why to distinguish we use the word this. Okay. Now this is out here. This is how we have done it. Now say instead of, if I go to this particular the class which we are writing, file reader. All right. Now here instead of throwing file not found exception, I throw training exception. Okay. Now what happens if I throw training exception? Control shift O. Okay. So if I throw training exception, what needs to be done? So here in this particular case, instead of throwing file not found exception, say I want to throw training exception. So, and why the error? First of all, see, I have declared this particular method to throw one kind of exception, which is training exception. But here if you see, the exception is which is getting thrown as file not found exception. So Java says that, boss, this is not possible. Either you have to add here that it also has to throw file not found exception. Okay, and that was in terms of Java legality this is fine, but otherwise it's not fine. Okay. Or if you want to or if you do not want to add file not exception, just remove the piece of code, because there's no other way it can be supported. And instead of throwing file not found exception, we'll throw a training exception. All right. So we come here, we instead of file not found exception, throw a training exception. The training exception was doing what? It was expecting an error code and a message. So I have error code, I have a message. All right. And both are strings, so I'll mention it as string. Okay. Here it is. Now it's done. Now if you see, for an example, now see one particular stuff which is very important is here we are throwing a training exception. Here we are not throwing training exception, we are throwing exception. Java compiler doesn't give any error. Why? Will it not give any error if I try to throw anything? Say for an example I throw file not found exception. Will it be fine with Java? Let's see. No. Why not? Because training exception and file not found exception are not related. Okay. But if you see exception, if I write exception, only exception here, the exception is a base class for all the exceptions, right? So if you remember, let's go back to the PDF and come here. So if you remember exception, the exception is a base class. It is a super class which every exception class has to extend. So that's the reason that you can either throw the same class, okay, or you can instance of the same class, or you can throw subclasses of the error class. So here either you could have thrown training exception, all right, or any of the super classes for training exception, which is an exception. Okay. Now say I do not want to throw an exception. I only want to throw file not found exception. What to do? Maybe this training exception which we are having has to not extend, say, very base level class exception. It has to extend file not found exception. So if we go here and let's modify training exception. Instead of throwing exception, instead of extending exception, it extends file not found exception. All right. So if we do that, this is how it is done. If you go here to file reader, the error is gone, because you either have to throw the instance of this one or any of these super classes. Now say instead of what do you say, file not found exception, here I write exception. Will it throw exception or will it throw compilation error? No. Why not? Because exception is a base class of every class, even the file not found exception. So in some way or the other, training exception is a type of exception, and there is nothing to be like say through compilation error about. So that's how it goes through. So here we discussed also about how to create our own custom exception classes, and how to fix, like say if you get an exception, what is a checked exception. So checked exception is say that Java as such, while writing these APIs, so what are these things? They are just files, right? There are some classes which were written by some big experts way down when the Java was being written, and they wrote such methods where they define these throws keywords. So whenever you are using it, you have to, this means that your program has to account for this particular error, either by fixing it in the same program by using try catch, okay, or by letting the exception propagate further by using the throws keyword. So these are the only two ways in which it can be handled. All right. So let's go back to the example here. Sorry, I'm in the PDF here. So this is exception which was described, and this is where we went back to the coding. So how to fix it? So how to fix it is you add this throws IO exception. And now coming back to what is unchecked exception. Like say if you see here, int x is 0, int y is 10, and int z is y by x. Now at compile time, Java doesn't try to see or do all the divisions and see whether it works fine or not. Why? Because it doesn't know in most of the scenarios what will be the value of y and x. Most scenarios are not as simple as what it is out here. So one of the rules which is there in compiler is not to check for such value. It just checks y by x and it looks valid, right? So it lets you compile it, and y by x, this by using this particular slash operator, you can do a division, all right, and it doesn't enforce that you need to throw some kind of error or you need to handle some kind of error. So since this was invalid because division by 0 is invalid, you get this java.lang.arithmetic exception. So this is a kind of unchecked exception, because there is no provision by whoever wrote that operator code or whatever that you have to handle it. Okay, in that case it is an unchecked exception. Okay, so I mean there is no way anything can be done about it. Now coming back to the methods which are there in the exception classes. So say once I create a particular method here, all right, so I have created this method training exception, and instead of throwing, I want to handle it in my code. So how to do that? So the way to do that is to encapsulate the thing within try catch. See here it says that since only this particular line is throwing the exception, all right, you have to encapsulate it within try catch block. But the best practice is in programming world, in the real world scenario, is all the code you write within try catch block itself. Okay, so that everything is covered out there as well. Now say this is how we write our code. So we have try and catch block. So inside catch, I want to see that what is the message which the Java has for me. So I go here and do sysout e dot get message. Okay, let's remove it, get message. Now let's try to run it. All right, you get the exception message. Hey, where is your file? Why? Because this is what you printed out here. Now the second one is print stack trace. So print stack trace means it contains the trace for the entire call. So say from here we're calling it file details. So get file detail is getting called. If from here we call in some other method, that method will be called. So if you want to see the entire trace, you call it the e dot print stack trace. Alright. So if I do this, you can see the entire stack trace, which normally happens. The exception trace which you were seeing last time, that is nothing but print stack trace. So it gives you the entire trace from where the exception happened, which are the lines of code which were involved. So all that information is available in the print stack trace. See here, it gives you the first line as well, that which kind of exception it is, what is the message, from where it happened, blah blah blah, and it doesn't go in it till this particular level. So it goes to the last level. So if there are 10 classes involved and the expression was coming in 10 classes, it will mention all those 10 classes one by one, from here, next one, next one, next one. So that is showing the entire trace. Okay, and that we can get using e.print stack trace. So these two are very important. I mean, e.print stack trace has, like say when you are using log4j, there is a different way to print it, but say this is one of the very important ways to see the entire trace. Okay, and if you just want to see the message, or maybe say get the error code. Now why we are not getting the error code here? The reason why we are not getting the error code here is that here in training exception, again going back to encapsulation principles which we discussed before, this is a private attribute, right? So to expose it, to use it outside, we need to add a getter and setter, which will be public. So that's how we will define it. So if we come here, and since we have generated getters and setters, so once we go here to file reader class, we can do it. Say e dot, say get error code. This is what we wanted to see, right? And you can go ahead and print it out. Maybe you can have a different logic inside cache block on the basis of the error code, and that's why you have assigned these error codes. But for now, just let's print it out. So it will give you this 100 error code once you run the program. Alright, see 100 error code is coming up. So whatever you define inside, all those things can be accessed. And apart from that, Java gives some other methods as well, like say hash code, toString, get cause. So I mean, but most of the things which are getting used is about print stack trace and get message, get error code if you have written your custom classes. All right. Now, again, I mean, now we understood till now what are the exceptions, but what to do with it? There are two ways to deal with it, right? One is that you either deal with it, say catch it, add a try catch block, or let it propagate further, which is using throws keyword. Okay, so let's come back here. So there are two keywords here. Okay, so let me start my word pad. So there are two keywords here. One is throws keyword, all right, and the other one is throw keyword. So if you come here, you see the subtle difference in this example itself. Now, while doing the processing, you think that the error has to be thrown, a new exception has to be thrown, you use a throw keyword. This is from within the method. Okay. So throw keyword is from within the method. Throws keyword. The throws keyword is something which is there in the method declaration, which means that this particular method can throw training exception. So the calling API, which API is application programming interface, or method in simpler words, has to handle it. How to handle it? Which I said in my own words, deal with it, which means add a try catch block, or let it propagate further, where you add throws exception here. Okay, so throws is with the method declaration. Okay, so this is the difference between throws and throw keyword. Now coming back here, multiple cache blocks. All right, now say if I come here and write an exception block. Okay, I've written training exception. So say training exception, for an example, let's go back here, and this training exception is not extending file not found exception, it's just extending exception. Okay, and we have a different exception from Java itself, file not found exception. So I want to handle both of them in my code. So if that is the case, what do? I can add catch exception for individually for both of them. And here, instead of throwing say training exception, in one case I can throw say file not found exception. Okay, and if say here I can go and write whatever I had written before about file reader. So I have this file reader class. All right, java.iu.filereader. rd is new, and here I define my own directory, and obviously the directory will not exist at t.ert/56.txt. This is the stuff. It forces me to add an exception, throws keyword. I added throws stuff here. See, two things are being written, and then it's done. So here I need to catch one more exception, right? Or I can just throw it further. So what you can do is that you can either add throws declaration, so you can say throws file not found exception, all right, or you can just add another catch block. So this catch block can be say like this: catch file not found exception. Okay, and then handle it here. So you can have multiple cache blocks. All right, so even if you are having multiple cache blocks, the other thing which is out there is that say you do not want to add multiple cache blocks, or the next question which you can ask is what is the significance in which we have all these cache blocks. So one by one we are writing all the cache blocks, right? So what is significance of the order? So the case of order is, say for an example here, I mean, training exception, right? So I just write exception here. So the cache block is handling the base class itself. So that means that in turn it will handle all the exceptions, right? So you will start seeing that this says that this is unreachable. Why? Because everything which is out here, every exception which happens within inside this try block will be handled by the catch, this particular block itself, the first block. All right. The second block is unreachable. So the first block which is capable of handling the exception is the block which will get all the work. So this block is going to do all the work, and this will never get invoked, and that's the reason that you get this compilation error. All right, so this has significance of the what do you say, for the subclasses relationship. So any exception class which is handled first and is capable of handling any exception class is capable of handling itself and all the subclasses. Okay, so exception class can obviously handle all its subclasses. So okay, even if I mean training exception, so if you go to training exception, it's just extending exception. So that's the reason that we are able to do it. What way it extends? File not found exception. So if you extend file not found exception, nothing is going to happen. And the reason that why nothing is going to happen is, I mean, you are not going to get an error is because, let's go here, nothing happened. Why? Because the first block which gets all the work is which is itself or its subclasses. So file not found exception is not its subclass. All right, now say if I flip it over, so this comes first and this goes in here. Now see, this block is saying as it's unreachable. Why? Because all the file not found exceptions or its subclasses, which in this case training exception, will be handled here itself. The first block will do all the work. This will never be invoked. So that's the importance of order of cache blocks as well. So you can have multiple cache blocks depending on your requirements, and the order is important. So make sure that we write it properly. Okay. Now I understood how to deal with it, but how to let it propagate and why. So how to let it propagate is using throws, and the reason of why is that maybe the place where you want to handle it, like say here, you're throwing it, because you can also catch it here as well, right? You can have a try catch block and catch the exception which when this exception class is throwing. So that can be done. Why we are not doing it? Because that place might not be the best place to handle it, or maybe the cases that there are many such methods and we need a central place to do the work, so we will handle it from the calling API. So there are multiple reasons which demonstrates that why we need like say this throws keyword, why we can't handle it there. It can be that we want to defer the execution of the error till the last the handling of the error at the last moment, or there's something in between, there's some other reusable piece of code which is already written. But in basic we can understand that the place where the error is coming up is not the best place to handle it, and that's why we want to let it propagate further. Okay, so that's what has been dealt here. Now the next one is the error was unexpected. I had to do something for sure. So say, right, if you're writing some blocks of code, all right, and the block of code is such that, I mean, you're trying to connect to a database. So if you're trying to connect to a database and you've already connected, but say after that you're trying to insert something and that is failing because maybe the insert statement formation is dynamic and you're doing some mistake there, and it's failing because of that. Maybe the table name which is getting appended in the insert statement is which is not there in the database itself. So what do you do in that particular scenario? So in that particular scenario, what you do is that, say here in this case, I've already defined a connection. That connection is open. So since that connection is open, all right, I need to close it, because if I keep on opening connections like this, after some time I'll run out of memory. I'll run out of connections because those connections are valid, they're important, they consume memory, and they stand for something. All right. So even your database can be pulled down if there are many open connections. After that, it will start refusing connections, saying that there are still open connections. Although modern databases handle it in a very good way, but there are I mean there can be errors, right? So what to do in that case? So the thing which can be done in that case is you write a finally block. Okay, so once you write finally block, the finally block means that this piece of code, anyways I will run it whatever happens. So if there is any error as well, this piece of code is going to get executed. So if there are some database connections, you can close them out here. Okay, and let's execute it. Like say if I write inside finally block. Okay, so here in this case we are getting exception, right? So let's even print that exception so that we are sure that it's happening. Say e.print stack trace here and ext.print stack trace here. And now let's try to run it. So we try to run it. See, it throws an exception, so you see the entire trace which is out here. All right, but still you see the finally block getting executed. So finally block will get executed anyways. All right, and let me tell you an interesting story about it. And what I'll do is that not in this class, because I generally give time to everyone to go and do a self reading on their own through this PDF, through internet, and then have their own understanding, and then we'll deal some questions on this as well. But I'll try to explain you how this works. So if you have, say, try, catch, and finally block, all right. So even if you throw say from this catch block, so here instead of doing this throw, I had this throw, but what I was doing is I was doing a multiple throw. So anything I'm going to handle it here. So what I mean is, let's say for an example, I have a try, all right, I have a catch block, and I catch trailing exception out here. And I also catch find not found exception. Alright, so this entire stuff goes within the try block, and here I write the finally block, and here I write this out. So this is finally block in get file details method. Alright, so from this training exception, what we were doing, we're again rethrowing the exception. We did it in one place, but we're just throwing it further. So we have throw exe, throw exe. Now in our case, as you've already seen, that exception will come up, right? So from here we'll anyways get the exception because we are throwing the exception, so this will get thrown further. So even if we are throwing this to the next level, before throwing it, so even though once you get a try block, you reach here, the exception comes. I mean the Java doesn't JVM doesn't throw the error at that point. It sees what else is there in this method, and finally block is there. So it executes this finally block, okay, and after that throws this error. So even though finally block as such will get executed only after try, catch, finally. And even if you have throw statement between, Java will not throw anything unless the finally block is executed. And let's execute it. So we'll write here sys out inside training exception. Alright, so let's try to run it and see what happens. So the first is inside training exception. So from here this gets called, you get an exception, it comes out here. Java doesn't throw the exception at that point of time, it waits, it goes inside finally block, you print this finally block and get details exception, then the exception is thrown. And once the exception is thrown, you come here, you come here, the stack trace is printed, right? And after that the finally block comes up. All right, and then here the finally block inside finally block comes up. So the throws statement execution, okay, throws throw execution is on hold, all right, until final block finally block gets executed. All right, so this was important, so I just wanted to tell you about it, and we will have some exercises around it, not for today but for next session, but you can do a self reading around it as well. So this is what we have for right. So we have for finally block where you write every stuff. So Java provides finally block to take care of anything which you wanted to do irrespective of the fact whether the error happened or not, and this is goes inside finally. So even if the error did not happen, in this case error happened, right? Say maybe the error did not happen, I did not do if the file name is null, we throw the exception, right? But the file name is not null, the value which you're passing is some value, not null, say 3 or some string, say inside this we have UI, just a simple string, just to avoid the error. If you run it, there is no exception, there is no training exception, but the finally block will get executed. So if you run it, you will not get any exception, but the finally block here and here, they both got executed. So that's how it is for finally, and this is how we this is where we understood about creating our own exception classes. So say I want to define error codes for different exception because this is what the client understands. How can we do this? So you create your own exception classes, how you extend exception, file not found exception, whatnot. And here the example which I have taken here uses insufficient funds exception, so that's how it has been defined here. All right, and again, you define attributes, you define constructors, then you define mutator and accessor methods to refer to the private attributes. And see here we are defining amount because maybe in this case in insufficient funds exception it has to have a reference to the amount which you're trying to withdraw to get the significance of insufficient funds, which anyways exception doesn't hold amount, right? Because that is very much specific to the code. So here you needed a new exception class, your own exception class, and this is how you do it. Now again, checking count is one particular class from here. Wherever there is not so much amount, you throw the insufficient funds exception. Then you have demo from where it's getting called. So again, they're just trying to execute that particular stuff. So this is all we had for exceptions. All right. I have some questions out here, and these questions are mostly on the basis of what will the output of the program. So go through it and try to answer it. It will clear some of your concepts. All right, and apart from that, the next thing which is out here is I have some programming questions from, like, say mostly it's output of the program, and then some theoretical questions as well, like say what is the difference between class not found exception and no class definition found error. So if you try to find answer for such questions, it will clear your theory concepts as well. All right, so this is out there for exception classes. Any questions?